Hi all. Good morning, good evening, in whichever geographies you are here. So let me introduce myself and let's start to see what topic we will try to talk today. So my name is Kiran, and here we are today to talk about logistic regression. So saying this, let's try to see what is that we try to cover in today's agenda. So we will try to talk what is regression, logistic regression, what and why, linear regression versus logistic regression, and we will try to see some use cases, and then we will try to see hands-on on how this logistic regression works. So in nutshell, we will try to understand for any kind of prediction what exactly is needed and how exactly logistic regression works, and we'll also try to compare how logistic regression is different from linear regression, and we will discuss about two use cases. Okay, so if you see and try to understand what is regression. So I understand we would have definitely known what are all the different types of learning: the supervised learning, unsupervised learning, reinforced learning. And if you have to talk about one particular segment, which is supervised learning, where we say that label data is the core crux for supervised learning. So what does it happen in supervised learning? Predominantly, whatever we are trying to understand or whatever we are trying to replicate, we have a supervisory information. In sense, somebody or some labeled information is available for us to take some decision. So this kind of learning where we have an additional help is supervised learning. Within supervised learning, we predominantly use two types of learnings, which is classification and regression. So if you have to see what is classification at a very high level, we are talking about bucketing. Is it A or B? Or is it male or female? And if you have to take an example, is it a valid email or a spam? So this kind of decision making is a classification. While coming to the other type is regression. So when we have to say what is regression, then regression is a predictive modeling technique. What do you mean by predictive? Which means anything which we can try to expect or anticipate based on some information what we already have collected. So that kind of expecting or predicting something for future is your predictive modeling, and for predictive modeling we use regression technique. So for example, if you have to say will it rain tomorrow, it's a prediction. What is the temperature tomorrow is a prediction, right? So we are trying to understand based on the given parameters what we have as of today, based on the weather, based on the month of the year, based on the geography where we are. All these considerations we try to take into account passively or actively, and try to say, given the month of August being in a subcontinent where it is a winter season or spring season, we probably say it might be X amount of degrees of Fahrenheit. So that kind of analysis where we try to predict something in the near future is your regression analysis. So if you have to read, it estimates the relation between a dependent, which is the target, and an independent variable, which is the predictor. So in our example of predicting the weather temperature tomorrow, we are all the parameters which we said, the month of the year, the continent, geography, everything is your independent variable, while the dependent variable is your actual temperature. So if you have to see a simple linear regression graph, you usually plot it on your X and Y axis, right? And the values which we have collected over a period of time is your scatter, which we see this, and within the scatter we try to put a linear relationship so it helps us to predict. So what we are saying is, for example, if you have to take and consider this X and Y axis as your real estate value, where your x-axis is representing the number of square feet in thousands, 5.5 or 5,500 square feet or 5,750 square feet, and y values is representing the price. Now, what we have done is for a given particular area with the transactions, what has happened, we are trying to scatter these dots. Now you are saying that, for example, a 5,750 square feet place is costing some 1 crore 8 lakhs, while a 6,000 square feet plot is costing plot or a flat is costing around 1 crore 12 lakhs. So this is the plot, which is the data gathered from your history, which we try to put across in your 2 dimension. So this dots are that scatter of information what we have collected from our experience or history. Then given that, we try to do a fitment, which is your linear line. And for example, one of your friend or colleague comes to you and says that I have 101 crore 30 lakhs, then you probably say you would be able to buy something around 7,000 square feet. Or inversely, if somebody says I am looking for a property around 6,000 square feet, then you probably say it might cost you anywhere between 1 crore 10 lakhs to 1 crore 12 lakhs, which is linearly proportional. Here if you see, for 7,000 square feet, it is concluding at around 1 crore 24 lakhs. So the input value is 7, the predicted value is 123.9. This correlation of finding things based on the data what is available is something called as regression. But here, if you have to see, the dependent variable is always directly or indirectly, it is trying to determine its value based on your independent variable. So given this, then we will try to talk about logistic regression, what and why. Right, we just try to understand what is regression, then we will try to say and understand what is logistic regression. So logistic regression produces results in a binary format. Predominantly, unlike what we saw in our previous example, it was a continuous format, but wherever we will have to do your prediction in your binary format, we will linear regression fails. So we will not be able to do the binary prediction using linear regression, and in that spaces you will have to use your logistic regression. So for example, if I happen to ask, will it rain tomorrow, it is yes or no, right? So when I have to answer discrete, it is yes or no, then I will have to use linear regression. So if you have to read this, linear regression produces results in binary format, which is used to predict the outcome of categorically dependent variable. So the outcome should be discrete or categorical, such as zeros or 1, yes or no, true or false, high or low. In such cases where our output is binary, then we use logistic regression. Sticking to the same weather example, if I am asking you what is the temperature tomorrow, then it is a linear regression. But if I am asking whether will it rain tomorrow, which has only two values, yes or no, for that you use your logistic regression. So this kind of regression where the output is binary, we will have to use logistic regression. But why not linear regression? Here, since the value of y will be between 0 and y, the linear line has to be clipped at 0 or 1. Here, when we see the linear regression, it passes through it. But our value for logistic regression should be between 0 and 1. So your line has to be clipped either at 1 or at 0, and then we have to proceed. So here, when for example, if it is of the weather, when it says will it rain tomorrow, then we said it is between yes or no. So it is like 0, between 0 and 1. You will have to clip it to be between 0 and 1. So how do we do that? With this, our resulting curve, when we clip, it becomes something like this, which is logistic in nature. When we clip it and combine it with 0 or 1, this is how we can make it. So which we also call it as a sigmoid or an S curve. If you happen to see, this was the linear thing. When we clipped it at your binary values, it became like this, which is nearest to one of the approach what we use in our regression technique, which is the S curve or the sigmoid curve. Saying this, here we will have to see what is the threshold value. So in this case, between 0 and 1.5 is your threshold value. Any value which comes above 0.5 less than 1 has to be put at 1, and anything between 0 and 0.5 has to be downgraded to 0, so that the value or the output or the regression or the prediction out of this can be binary in nature. So with this, the threshold value indicates the probability of winning or losing. So with this, the threshold value indicates the probability of winning or losing. So, but how do we mathematically do this? We have a equation which we derive. So we know the equation of straight line is equal to y is equal to mx. So then let's try to reduce the linearity quotient or the straight quotient, because the straight quotient, the range is from minus infinity to plus infinity, while in logistic regression we need it to be between 0 and 1. So when we have to make it between 0 and 1, this is, we will start with 0 to infinity, that is y by y minus 1. When y is equal to 0, then y becomes 1 to infinity, and similarly the other way around, when we have to make it minus infinity to plus infinity, we will add this into the log, we get this equation. But the good part is we just have to know the math of this particular thing. When we are using the machine learning algorithm like logistic regression from scikit-learn or any of the libraries, this mathematical formulas are taken care within the function. We will have to pass the parameters and get the output. So once we have that, then we just do the fitment and get the output. So if this is logistic, then let's try to see at a very high level, which we have already tried to compare, how is logistic and linear different. So in linear we get continuous variables, while in logistic we get categorical variables. While linear regression tries to solve regression problems, while logistic tries to solve classification problems, because it is 0 or 1. And in linear regression, the line is straight line, that's the reason why we call as linear. And here we have a logistic, we have an S curve, which is the indication which we saw. So that is how it is, that is how both linear and logistic regression differ. So it is continuous versus categorical versus regression versus classification, and straight line versus an S curve. So saying this, let's try to see some day-to-day use cases on logistic regression. So logistic regression, like we started off our discussion, one of the evident use case is our weather. So weather predictions, where we try to see, for example, this is the weather prediction of a given city, and we have the temperature, we have the humidity or rain forecast. So the temperature prediction is the linear quotient of it, while the rain prediction is the logistic quotient of it. And if you have to talk about the classification, there are so many classifications, or basically Python in scikit-learn helps you to do a multi-class classification. So if you have to take this example of vertebrates, we have an amphibian, bird, fish, mammal, and reptile. So if you have to see whether a crow is a bird or a mammal, so this is a classification which we try to see. And if you have to see from the healthcare, determining the illness for a given patient based on the various parameters, is other classification. So an ideal example is when we do a blood test report, right? When we get our blood test or blood sample test report, we have two columns. One is your value and one is the reference value. So if our value is in range with the reference value, we say it is okay. If it is out of range, it is not okay. So these are the two classifications which helps us to determine whether a patient is ill or not ill. Now let's try to see how to implement logistic regression. So when we say logistic regression, like any other algorithm, we have these 5 steps where we will have to collect the data, analyze the data, clean the data, which is called as data wrangling, train and test the data, and then do the accuracy check. Okay, so coming back, the implementation of logistic regression, we said like any other algorithm, we have this 5 steps where we do the data collection, then we do the data analysis, then we do when we say data collection, it is basically sourcing of the data to see where we can get the data required for our problem solving. Then we do your second step, which is analysis of our data or analyzing our data, where we try to do some visualization, try to see a fraction of the data or see the data in various variations so that we can understand how to proceed further. Then we do the data wrangling. When we say data wrangling, it is predominantly cleaning of the data. So when I say cleaning of the data, we might have the data which are probably with missing data or data which is not completely filled or a fraction of the data, continuous data, static data. All these enablers have to be addressed as part of your data wrangling. Then we go ahead and do training and testing, where once we have a data which is clean enough to be consumed, we particularly fit that into our training model, and then we do the testing, and then we do an accuracy check of the model before we can use it for any of our applications. Okay, let's try to see a simple example where we will talk about the survival rate in the Titanic ship. We basically have a large data set, and we all know that Titanic ship was one of the famous ships in its time, which did sink in its maiden travel, and this had a large quantity of people who were on board, and this data gives us immense coefficients for us to analyze. So let's try to take that data and see how we can see the model what we were discussing. Okay, let me show you the data what I have for the Titanic ship. So if you see this, there are like 3 plus 3 6 plus 3 9 plus 12 columns of data. We have the first column as the passenger ID, the second column as survived. If it is 0, if it is not survived, if it is 1, it is survived. Then we have P class, where the class in which the people traveled. There are 3 classes: 1, 2, 3. Class 1, class 2, class 3, like your first class, second class, and third class. And then you have the name of the person, then you have the gender, then you have the age of the people who traveled, then you have SIBSP, which means that number of siblings who travel, and you have the parts, which is the total number of parents who traveled if it is a kid. And then you have your ticket number, you have your fare, and the cabin details wherever the people were traveling in the cabin. And you have something called as embarked, where you have 3 things, where S, C, and Q. These were the 3 places from where the ship did allow people to board the ship. So seeing this data, let's get into our Jupyter notebook, try to see how we can import the data and how we can model our data. So if you have to see, let me try to use my libraries. We are importing this libraries: pandas, numpy, cbarn is your plotting library. Then we have our matplotlib, which is also the plotting library, and we are importing the math function. So once we have this, we will define our data frame, where we using pandas, the data what we said titanic.csv, which we did see, we will import that, and we will see the first 10 lines of the data. So if you have to see this, this is the first 10 lines of the data. Now this, once we import this library and once we take this data into data frame, let's try to see some analysis on this. If you have to see what is the total number of passengers in this data, we just try to see the using the length function on the Titanic data using our index function. And if you see this, there are like 891 passengers. The number of passengers in the original data is 891. So if you have to see in the Excel sheet, predominantly we have this 891 records. Okay, so 892 including the header. So once we have the data, we said that was our first step of collecting the data. And if you have to see, our next step is analyzing the data, right? So then what we said is the second step after we get the data is analyzing the data. When we say analyzing the data, what we try to see is, let's try to see and using our Seaborn library, where we have defined it as SNS. Let's try to see the number of people who have survived, where one is survived while your zero is not survived. So if I have to run this particular thing, so basically the number of people who survived are around 300 plus, while the number of people who did not survive are around 500 people. And if you have to see one other dimension of it based on the gender, then let me do the same thing with the count of plot. I bring in a parameter of gender using who, and if I have to run this particular thing, then I will get that the number of male people who did not survive are higher, while the females who survived are higher versus the number of male who did not survive. If you see this, the blue graph, which is your male, did not survive, while the female graph who survived are higher. So this was based on the parameter of gender. And if you have to see based on the parameter of the class of ticket what they have bought, if I have to run this, so if you see this, basically the class 1, class 2, class 3, the three classes what we had, and this is our survival rate. So predominantly the class 3 people did not survive a lot, while the class 1 and 2 survived comparatively higher based on the total number of people who were there. So if you see in class 1, this were the number of people, around 60 or 80 people did not survive, while 140 people survived. While if you have to see the class number 2, around 100 people did not survive, while the same number of people survived. And in class 3, around 350 people did not survive, while around 100 plus people survived. Now with this, let's try to see the plot of what is the age of the people who are there on the ship. So if you have to run this, you see the maximum number were between 0 to 40 years. So between 0 to 20 there was around 50-60 people, and between 20 to 40 were the maximum number of people who were available. This is what we have as part of the age. This was our histogram or the plot graph based on the age. And if you have to see a similar thing on the fare, so we had various fares here. Let me try to run my thing on the fare. So if you have to see, between 0 to 100 was the maximum fare. There were few instances of 200 or 300, and the number of people between 0 to 10, if I'm right, so had paid the maximum fare or the maximum collection of the fare, and that was the thing. Now let's try to see the data itself. We are saying Titanic data underscore info or dot info, basically, which gives us the information about this data. Here it is saying there are 12 columns in total, 890 values. Then we have the passenger ID, the survival ID, the age. We have like 714 rows have age, while the remaining does not have. There are 204 rows which have the cabin details, the remaining does not have. While in embarked there are 889 columns which have the data, while the remaining two does not have. So the function dot info gives us the details of the data. Then if you have to see the based on the siblings, what we did see one other column, I am just passing SIBSP into the Titanic data. So the maximum number of people were without siblings. There are few people here which we have the details. This is all for our analysis. Once we have this analysis, we did try to see the data in various shapes and forms. Then our going back to our presentation, the second step, and basically here we did our creating different plots to check the relationship, and then we did different plots to check the variables, so like where we did the gender or the class of the things. Then we will have to do our next step, where we will do our cleaning. So when we say cleaning, basically there are so many columns within the data which does not have the value. So when we did see our describe, we said that there were few columns within the cabin which was not filled with data. There were columns in age, it was not filled with data. So those columns have to be addressed before we can address it. But first, if you have to see this, let's see which are all the columns in this Titanic data which have no values. If I have to run this, you see this, these are all the columns, or these are all the things which are available with no data. Then the true and false indicate there is a value, or no, there is no value. And then if I have to go and see the summary of this at a summary level, if we run this, basically it gives that in passenger id or survived or p class, all of them have the data, while in age there are 177 records where there is no age populated, and in the cabin there are 687 records where there is no cabin details populated. And within the embarked column there are two records which does not have the value. After this, what we will try to see, the same thing, let's try to see visually using a heat map. So if I have to use the heat map, I will use my cborn library, calling the heat map, passing the data from my Titanic data, and let's try to run this. So if you have to see this, here the column which is in age does not have few records, and the things with the cabin does not have, and the one which embarked, because only two records, it is just we see a light yellow color line here. And that is how from a heat map perspective we are trying to see this particular thing. And if you have to see the same thing based on the class using our candlestick approach, we get to do a box plot and pass the values of age and class. And based on the age and class, we get to see this is the first class, second class, and the third class, and the age between 30 to 50 in the first class, 25 to 35, and 20 to 35 in the third class. That is how we get to see. Now with this, let's try to see what data which we will have to clean. We said that basically, right, we have some data which we will have to convert the strings into our integers. That is one thing. And wherever we don't need the data, also we will have to drop that particular thing. So one of the thing is the cabin, which predominantly 687 records out of the 900 records does not have cabin. So there is no point we keep in that. So we can go ahead and drop that particular thing from our data set or our data frame. And if you have to run the records, we will get our new data frame without that cabin details. Then we will also try to drop in as in place is equal to true. Let's do that. And then if you have to see data, how clear it is, when we have to see the same heat map which we previously run. Now if you see this, all the values which were of not available, we did clean that particular data. So our heat map now is completely clean. Then if you have to run the same thing using the same value what we did Titanic data with the summary, let's run this. So if you see, the columns which we are using now has all the values, so there is no columns without values. And we are trying to see a few records, two records out of that data, and these are the two records. Now In this, what is happening is, where we have this gender or sex, we have a male or a female, which is a string value. And regression models, or any models for that matter, cannot handle the strings effectively, or we will not be able to do any modeling with strings. So we will just convert that string into a integer. So how do we do that? Basically, we are trying to convert that into, if it is male or female, by 0 or 1, and then we try to run this. So our male and female got converted into an integer. Similarly, we have embarked, which is also a, it is a string which we will convert into the string, because we had three values here. There were three places from where the people boarded the ship. So we will use that, and we will convert that into the numbers 0, 1, 2, 3, and we get that Q, S, and C values. Once we do that particular thing, we also will drop the first, second class, because we don't need that. Or basically, there are three classes, because if you say if it is 2 or 3, then obviously the one which is 1 become which is not 2 or 3 becomes the first class. That is how we reconvert that. And whatever the fields which we have changed, let's, okay, we have changed, let's try to concatenate all of them, and try to see our new data set, which is the 5 records from the new data set. So this is how we get this particular data set. And then we will drop the values which we don't need, like the male, which we had the gender, the embarked, which we had SC, the passenger ID, which is just the number 0, 1, 2, 3, 4, the name, which is a pure integer, which is, sorry, pure string, we don't need that. And the ticket number which we have, which is a combination of integers and values, which is also a string format, just we will drop all of this from our data set, and we will get a data set which is just integer in total. So if you see some records, the survived, P class, age, sibling, patch, fare, everything became into an integer. Oh, I think we did not do the P class. Let me run this. Okay. So once we have this data which is cleaned, then we will have to do our next section, where we said train and test. So this is where we try to build the model, train, and try to predict the output using our test data. So let's see how we will use the functions which are available from some of the Python libraries to train our data. So when we said this regression, we will have to take both the dependent and independent variable. Now we have our x value, where we say survive, and the y value, which is basically our y value is a dependent variable, and your x value is independent variable. So basically, using this, we will try to run this, create the data for our x and y, and we will try to split it. We will have to split this train and test using the scikit-learn cross validation. We will use the import train test. We will run this, and then we will basically run the test and train using the parameters which are available as part of this train test split. Then we will use our logistic regression. Logistic regression is also function within your scikit-learn under the group linear model. So you have sklearn.linear model import logistic regression. We are just importing that, and we are assigning variable log model to logistic regression. Once we have our log model defined, we will have to train that particular thing. So we will use that log model dot fit using our x train and y train parameters. Let's try to run this particular thing. We see the various parameters which have come after training. So once we have this log model where we did run our model, we will try to do the predictions using that predict function within our scikit-learn. So we do that predict, and then run a classification or confusion matrix on that particular thing to see how our predictions work. So this is the values which you get, but let me try to explain you in detail. When we run the confusion matrix, we get a matrix of 2 cross 2. This is your confusion matrix, where we say 105 versus 21 plus 25 by 63. If we have to see this, let's come here and see how does this work, which is basically the actual versus the predicted. So in actual, if you have 0 which is positive, 1 which is negative, and in predicted, if you have 0 positive and 1 negative. So if this is actual and predicted both are positive, then this is called as true positive, which is the actual condition is positive and it is truly predicted as positive. The model has truly predicted as positive. And if it is false negative, where the actual condition is positive while it is falsely predicted as negative, which becomes Fn. Okay, now when we see that confusion matrix and we have to see the accuracy, if you have to see from our deck what is accuracy, accuracy is the true positive plus true negative. Here the true negative is the actual condition is negative and it truly predicted as negative, and TP is true positive, where the actual condition is positive and it truly predicted as positive. Basically the accuracy is the sum of this by addition of all of this. So with that value we get 76 or 78.5. So the accuracy of this model is just 78%. Probably we need more data to get it to a higher level and use this model to predict the survival rate using the logistic regression. So this was our humble effort to see how we have a small data set of Titanic ship and trying to model a logistic regression and trying to predict. Similarly, we can take one other use case where we will do the SUV data analysis. So what do we do here? Basically, a car company has released a new SUV in the market, and using the previous data what it has about the sale of their SUVs, they want to predict the category of people who might be interested in buying this. So let me try to show you the data what we have for SUV. So we have this data where we have an user ID, the gender, the age, estimated salary, and from the previous history of buying the SUV, they have the indicator 0 is they have not bought, 1 they have bought. So let's go to our Jupyter, try to import our data. So where we first import our libraries, import NumPy, import Matplot, and import Pandas. So let's run this, and I have my data set which is the SUV predictions. If I import that data, let me import the data. And if I have to see this data from the data set what we just imported, so this is the data what we have, the top 10 records, the top 10 records, the user ID, gender, age, estimated salary, purchase. Then we will go into assigning the X and Y, where here X is your data set using our function iLock. So basically we will have to need the data for our X, which is the iLock is the index. So if we are saying this, the column 2 and column 3, which is your age and estimated salary, and here for your Y we are trying to use the prediction, which is your purchased, which is your fourth column, and that is how we are building our X and Y. If I have to see my X value for a minute, so let me run my X and Y and let me try to see my X. So if you see this, the age and the earning is my X and Y, and if I have to see the Y, this is my Y zeros and ones, where whether he has bought or he has not bought. Then we will use the same train split model. Now, like how we did when we were doing the Titanic thing, we will do from the scikit-learn module. We will use this train split, and then we will pass the parameters into the X train, Y train, and then we can do one scaling. Basically, this is a standard scaling procedure where either to scale up or scale down, so that if you don't have good amount of data, we can use this standard scalar functionalities before we can do our fitment. So when we say fitting, it is basically the training. So we did X train with the fitment and transform the X train, and then we will use the same logistic regression model using the import logistic regression approach. And then we are using the classifier within the logistic regression, and these are the parameters which we get out of our logistic regression, where it gives you our random state details and the class details. Once we have that, let's try to predict. And if you have to say, we are predicting, and we will try to see similarly the accuracy score. Here if you see, the accuracy score is around 89%. Previously it was 78%, if I remember, in the Titanic score or the Titanic data, while in your SUV prediction, the accuracy quotient at this point of time is 89%. So if you have to feed this model with new data, the accuracy with which we can predict whether a person will buy or will not buy an SUV is at 89%. Now, if you have to see the journey towards the data scientist, predominantly this is a job description from one of the MNCs. So you see that basically they would have the need of the hour is predominantly on various parameters in statistics, programming, and especially in extraction, data wrangling, and data visualization, and machine learning algorithms. So a right combination of all these things is needed for us to do some uniquely blended algorithms. Okay, and with all these things, we basically have many of our courses which are available for enrollment on edureka.co. So basically we have the Python certification, machine learning certifications, deep learning certifications, which we have it. And there are various courses with fee structures and real-time projects which will be part of our overall thing, which helps us to keep up with our changing requirements and get market ready for our career shifts or career hops. Okay, so this was an humble approach to give us brief background on how do we use a regression and what is logistic regression. I hope we enjoyed the session. Thanks for attending it. Thanks everyone. Thanks for your time.